In this tutorial, we're going to show you how to download data from MARIS, the Mississippi Automated Resource Information System, and it's going to be some basic county data sets that are going to be in shapefile format. And then we're going to create a geodatabase structure and import the shapefiles into the geodatabase as feature classes. So the first thing I'm going to do is open up a web browser, in this case Mozilla Firefox. And we'll wait a second for the browser to open up. Okay, now I'm going to use the Google search engine and type in MARIS, M-A-R-I-S. And it should be the first hit here, which indeed it is. So I'm going to click on the MARIS link. Now, all kinds of stuff available on the MARIS website. If you have any questions about it at any future date, please go ahead and get in touch with me, and I'm happy to answer any questions, or you can contact them directly, or I encourage you, if you have the time, to go ahead and explore their website. So I'm going to go to the download data link and to county data, and what we see here is a list of each county, and they have standard county data sets and other county data sets. If we click on these links up at the top, it'll give us a definition of the data sets available within these download files. I'm going to click on standard county data here, and we can see that the 10 data sets are county roads and city streets, census places, etc., etc. So I'm going to close that, and in this case we're going to go ahead and do Oktibbeha County. So I'll scroll down to Oktibbeha here. And here's Oktibbeha. Now we have two different options here. We can download the data in Mississippi Transverse Mercator Projection or in latitude longitude, which is just a geographic coordinate system. That's not projected data. Essentially, I can download either one of them because I'm going to reproject all my data once I download it anyways, but I'll go ahead and download the data in MSTM projection. So I'm going to click on Oktibbeha exe right here, and it'll start downloading this file, or give me the option to save the file. So I'm going to click Save File, and the data has been downloaded. So I'm going to right click on that file now, go to Open Containing Folder, and here's the file I just downloaded. So I want to move that to a different location. I'm going to right click on that. I'm going to cut that, and I'm going to navigate to, in this case, my C drive, temporary directory, and I'm going to create a new directory called County Data. Navigate into that directory, right click, and paste oktibbeha.exe. Now in order to unzip this, I can just double click on it, and it will run my executable file, and I'm going to browse to the output location where I want to unzip this data, and I'm going to navigate again to C, temp, county data, and click OK, and let's go ahead and unzip this data now. So 41 files unzipped successfully, so we'll click OK to close that window, and we'll close the WinZip self-extractor window. Now what's occurred here is that the oktibbeha.exe file has been extracted to this Oktibbeha directory. I don't need the executable file anymore, so I'm going to delete that. Yes, let's delete that. Double click on the Oktibbeha directory. Now within here I have a bunch of shape files. So multiple files are associated with each shapefile. So in the case of CO 105, I've worked with these files a lot, so I know that that is the county boundary shapefile. We've got multiple CO 105 files. 105 is just the county code. So we've got a DBF, a projection file, a .shp file, and a .shx file. So again, with shape files, they consist of multiple files when we're viewing them in Windows Explorer. So let's go ahead and minimize Windows Explorer now. We can close our downloads page, and we're going to minimize our internet window here. Now let's go ahead and open up ArcMap. Here you can see that I'm running version 10.1. So I'll open that up from my desktop. And it will make us patiently wait here for a few seconds to open. Now, once we open ArcMap, we're going to add these shapefiles to our map and just view them real quickly. Just explore the data very briefly. Once we're done with that, we're going to go into our catalog, create a new geodatabase and the geodatabase structure. Then we'll import those shapefiles into the geodatabase. So let's give it just another second or two here. Alright, now I have the option to open some existing maps that I've recently worked on. I want to open up a new map, so I'm going to click on My Templates under New Maps. And standard default is blank map, so I'm going to select that and click OK. So now we have an untitled ArcMap document open. Over here, we have the catalog window. And this little button right here, the auto hide button, looks like a little pin that's sticking down, so the catalog window is going to stay open for us. If we click that, then the catalog window will disappear when we move our cursor off of the catalog window there. I'm going to expand my folder connections directory. The only folder I'm connected to is the C drive, root C drive. I'm going to come up here, click on connect to folder, and we're just going to create a shortcut to that directory where our data is located. So I'm going to double click computer, double click C drive, scroll down to temp, oops, expand that out, click on county data once, so now this is my new folder connection, C temp county data. So let's click OK. Now you can see that that folder connection exists over here. So we can navigate directly to that directory, to Octibaha. And I'm going to expand that. Here we can see all our shape files. Now notice when we're viewing these in our catalog, it only shows one file for each shape file. Again, if we view them in Windows Explorer, it's going to show all the files that are used to compose a shapefile. So if we want to copy and paste these or cut and paste them to a different directory, easier to do it in Arc Catalog, to manage all your data in Arc Catalog. So I'm going to go ahead and click and drag these one at a time over into my map. So CCO 105 is county roads. City 105 is city boundaries. CO 105 should be the county boundary. Inter 105 is intermittent streams, or streams that don't run year-round. Paren 105 is perennial streams that do run year-round. PLS 105 is public land survey system information. Let's add that to our map. That's 1 square mile grids, which are used for surveying purposes. PRI 105 is primary roads. RRDS 105 is railroads. SEC 105 is secondary roads. And finally, WAT 105 is water bodies. So we've got all this information added to our map. Now by default, the polygons draw towards the bottom in our table of contents. Lines draw on top of polygons. If we had any points, they would draw on top of the lines and polygons. So the order that these layers are listed in the table of contents is the order that they're going to draw on the map. So if I took my county boundary, clicked and dragged it to the top of the table of contents, county boundaries covering everything else. So works just like pancakes, right? So whichever pancake's on top is going to cover everything else. So if I want to turn all these layers off at the same time, I'm going to hold down my control key and turn one of them off by clicking on the checkbox. Turns them all on and off at the same time if you hold down the control key. So one at a time we can view secondary roads, railroads, primary roads, perennial streams, intermittent streams, county roads, water bodies, public land survey system information, which again are 1 mile square grids for the most part. There are some slight deviations from that. City boundaries and the county boundary. So 10 base data sets that we've downloaded here. Now, we're not going to get in depth on this, but you always want to be concerned about data quality issues. Now, these data sets are not super accurate, but we're using them for demonstration purposes so you can see how to download some shapefiles and then how to get them into a geodatabase. So we want to create a new geodatabase now. So in the Octibaha directory, I'm going to right click on that, select new, and I'm going to create a new directory here and just call that geodatabases. Now within the geodatabases directory, I'm going to click on that, right click, and select new. Now I can create different kinds of geodatabases, file geodatabase or personal geodatabase. Typically I create a file geodatabase, unlimited storage. The only limitations are a feature class or table can't be larger than 2 terabytes, which is gigantic. Personal geodatabase is limited to 2 gigabytes. So I never use personal geodatabases. I'll use a file geodatabase. So I'm going to select that. Now we've created our new file geodatabase, and I'm just going to call that Octibaha. Name it after the county because that's where we're going to store our county data. Now I want to create some organizational, essentially they serve kind of as directories within our geodatabase, help us organize our data, and they allow us to perform some advanced functionality. I'm going to create what's called feature data sets. Now, if I look at these 10 shapefiles that we've downloaded, some of them are administrative boundaries. Some of this information has to do with survey information, which is also called cadastral, right? Anything having to do with survey measurements. Some of this stuff is environmental stuff, like the streams and water bodies, and some is transportation stuff, like the railroads and roads. Now, how you organize your geodatabase is up to you ultimately. This is just, again, for illustrative purposes. So I'm going to create a new feature data set. So I'm going to right-click on my geodatabase, go down to New, Feature Data Set. 3 little patch symbol always indicates a feature data set. So I'm going to click on that. I'm going to name this one admin and store my administrative boundaries in here. I'm going to click next. Now, anytime you create a feature data set, you have to assign some kind of coordinate system to it. It could be an unprojected coordinate system that's in geographic coordinates, or it could be a projected coordinate system. Typically, in many cases when working with data in Mississippi, the state plane coordinate system is used, as that helps eliminate most distortions in our map projection. Octibaha in Mississippi, there is a Mississippi state plane east and a west. Octibaha is located in the east part of the state, so that's the projection we're going to use. Let's click next. We don't have a vertical coordinate system, so we'll click next. I'm going to accept all the tolerances here. That's pretty standard. I never change those tolerances. I'm going to click finish. Now I've got my new feature data set created in my Octivaha geodatabase. Instead of going through the process 3 more times to create my other feature data sets, I'm going to right click on admin. I'm going to select copy. I'm going to right click on the geodatabase and select paste. Now I see some red text up here. Anytime you see red text, it's some kind of indication that you need to pay attention. All this is telling us is that we're going to go ahead and paste a feature data set that's named admin, but there's already one named admin, so the new one's going to be named admin_1. That's fine. We'll rename it after we paste it. So let's click OK. Now over here I can click on admin_ once, then I'll click on it again and I can edit the name. I'm going to name this one transportation. I'm going to right click on my geodatabase again, select paste. It will paste that admin feature data set again. Let's click OK. Click on admin_ once. Click on it again. We'll name this one cadastral. Again, you can name these whatever you want, right? It's up to you ultimately how you want to organize your data. And we want one more feature data set, so I'm going to right click, select paste. We'll click OK to paste the feature data set. And we want to name this one environmental. So now we've created our geodatabase with 4 feature data sets in it. What we're going to do in the next step is import these shapefiles into the appropriate feature data sets as feature classes. So the feature class is going to function somewhat similar to the shapefile. We can add them both to the map. They'll look exactly the same, but they're stored differently. And ultimately, they're stored more effectively and offer more functionality if we store them in the geodatabase. The geodatabase symbol, to me, looks like a little can. And essentially, we're canning all our data in one central location. So let's go ahead and get the city boundaries and county boundary into the admin feature data set. So I'm going to right click on admin. I'm going to go down to import. And I'm going to select feature class multiple since I have more than one feature class, which is essentially a shapefile as a type of feature class, right? The technical name for it is a shapefile, but it is a feature class, just as the technically named feature class stored within a geodatabase is a feature class, okay? So that's a little bit confusing to some people, but use this functionality to import shapefiles into a geodatabase as a feature class. So let's select feature class multiple. And our feature class to feature class tool should open up in just a second here. Now, the input box is the input features. The little green dot indicates that that's a required parameter. Sometimes tools have some parameters that aren't required, but we know that's a required parameter. We could click the Browse button and navigate to the shapefiles we want to select, but easier than that, let's go ahead and just click and drag city. So we'll click, hold down our left mouse button, then let go of it here. It'll add city 105 there, and let's grab our county boundary as well. Click and drag that, and then drop it in this window. I must have let go of my button there. So it's being stubborn with me here. There we go. And we can see the output location is the admin feature data set because we initiated the import from that feature data set. So let's click OK here. And sometimes you get a little status bar down at the bottom indicating that the tool is running. Sometimes it disappears, but once the tool is done importing those shape files to the feature dataset as feature classes, a little notice will pop up here. So let's just hold on for just a second. And it'll make us wait patiently. Sometimes I like to sneak up here. I'm going to expand admin. Okay, city is already in there, so it must still be working on the county. Aha, so this indicates that the feature class to geodatabase tool is done running now, or that functionality, and automatically it adds those to our map once we import them. So let's go over here and delete some of these. So I'm going to select, we want to delete the shapefiles we added previously. So I'm going to click on this first one. I'm going to hold down Shift, select this one, and it selects all of those. I can right click and select Remove. Now these two are the two feature classes we just imported. And actually we're going to want to rename these. So let's just go ahead and select everything here. So I'll select the first one, hold down Shift, select this last one, and remove. As we're going to want to rename these so they have a more meaningful name. So let's go ahead and click on City 105, click on it again, and we'll just go ahead and rename that Cities. Okay, again, you can name it whatever you want. Okay, now it's got a schema lock because sometimes when it adds it to ArcMap, it just gets fussy. Now it thinks it's still added to the map. Let's see if we can rename it again here. And this schema lock, you may experience it periodically. Essentially what I'd have to do here is close ArcMap, open it back up, and then navigate into our catalog and rename these. So it's something that's kind of fussy sometimes. So just be aware of that. So we're not going to rename them right now. We're going to go ahead and import PLS 105 into Cadastral. Again, Cadastral has to do with survey-related measurements. So in this case, we could right-click on Cadastral and go to Import, but there's another way to do it. I can right-click on PLS here, the shapefile, and go to Export to geodatabase. In this case, it's a single shapefile that I want to export, so we'll do to geodatabase single. Now the input features are already specified. The output location, we want that to be the cadastral feature data set. So we're going to click and drag cadastral into the output location. In this case, since we're only doing one file, we can give it an output feature class name. Right? If we did multiple, then it just uses the original names, as you can see when we did city and county boundaries. So here we're going to call this PLSS underscore sections. Anytime you want a space in a file name, ArcMap doesn't like that, ArcGIS doesn't like that, so use an underscore. So we've got all our input parameters specified, so we're going to click OK. Now you can see down here the tool is running. There, and it's done, so we can close this. If we don't, it'll close on its own, and it's automatically added to our map. So again, it looks just like the shapefile, it's just stored differently in a geodatabase as a feature class now. So let's right click and remove that from our map. Now let's go ahead and import streams and water bodies into environmental. So we're going to right click on environmental, go down to import, feature class multiple, and here we'll go ahead and click and drag enter 105, which again is intermittent streams, paren 105, which is perennial streams, and WAT 105, which is water bodies. So we've got all our input parameters specified now. Let's click OK. And you can see down here that the tool is running. And as soon as it's done, it'll add these new feature classes to our map. So there's our new feature classes. As I said, if we don't close this, that should disappear on its own. So there we go, right? So just wanted to point out that functionality. Now here, right, it's listing the name of the feature data set and then the feature classes that are contained within that feature data set. So essentially, when we imported those feature classes, it added that environmental feature data set to our map. And that contains, again, those feature classes. We're going to right-click on environmental. Let's go ahead and remove that for now. So again, we're going to want to go back and rename these. And we'll probably have that little fussy schema lock. Finally, let's go ahead and import some transportation related shapefiles. So we'll right click on the transportation feature data set, go down to import, feature class multiple, and we want to import CCO 105, which is county roads. Let's see what else we want. Pri 105, which is primary roads. RRDS, which is railroads. And SEC 105, which is secondary roads. And all our input parameters are specified. Those are going to be imported into the transportation feature data set. So let's click OK. And our tool's running, so we'll wait patiently for a few seconds here. And it looks like we're done. So now we've got the transportation feature data set and its associated feature classes added to the map. So let's right click on transportation. Let's go ahead and remove that. As I said, this schema lock gets a little fussy sometimes, right? Since we removed those feature classes from the map, we should be able to rename these now. But let's go ahead and try that again. So I'll click on CCO, click on it again, and try and rename that county _ roads. And I bet it will not take, right? Failed to rename selected objects. Cannot acquire a schema lock because of an existing lock. So for some reason, ArcCatalog thinks that these things are still open in ArcMap. So that's fine. So I'm going to show you some other stuff here anyways, so it's okay that we can't rename those. So again, just a little reminder, we're in ArcMap, but we can sneak into ArcCatalog while we're in ArcMap here. So we have the ArcMap application open. We can open up ArcCatalog as its own separate application if we want. So I'm going to close ArcMap. Let's not save changes to our untitled map document. Now I'm going to go to my ArcCatalog desktop icon and double click that to open up ArcCatalog. So again, when we're in ArcMap, we could essentially kind of sneak into ArcCatalog. Here, this is ArcCatalog as its own separate application. And we've got that folder connection set up to our county data directory. So I'm going to expand that, expand Octibaha, expand geodatabases. Now, since I've already imported all these shapefiles into my geodatabase as feature classes, really, I could go ahead and delete all of those if I wanted to. But for now, we'll just leave them there. Let's expand our geodatabase. And now you can see over here in the catalog tree, when I'm in ArcCatalog, I can expand my geodatabase and all the contents. Additionally, over here, all right, if I've got my geodatabases directory selected, it's going to show me the contents of that directory over here, which is only that geodatabase. I can double click on the geodatabase here, and it'll show me the contents of the geodatabase, which is all of my feature data sets. If I want to know what's in cadastral, I can double click on that. It's going to show me the feature class that's stored within that cadastral feature data set. All right, so different ways of viewing. Now here I can view everything collectively. So here's my entire geodatabase structure. So we want to go ahead and rename some of these feature classes. So I'm going to click on city once, click on it again so that the name is editable, and let's rename this to cities. Now when I click off of it, it should rename, and indeed it did. Right, but it expanded some of our other, or excuse me, collapsed some of our other feature data sets. Let's do the same thing for county. So we'll just rename that county. Again, I'll keep reminding you, you can name this stuff whatever you want when you set up your own geodatabase. This is just for demonstration purposes. Cadastral, since we only imported one feature class into cadastral, we were able to name it when we ran the tool. So that's named appropriately. Let's expand environmental, and we'll click once on Inter 105, click on it again so it's editable. Intermittent streams is what we'll call that. Let's rename paren to perennial underscore streams. Oops, and that should be an EA. I make no claims to be an English major. But I know what the stuff means. And let's rename water to water underscore bodies. Again, you want to, right, we want to name our feature classes, our feature data sets, things that have pretty explicit, right, well understood names. CCO 105 is county roads, so let's rename that to county underscore roads. PRI is primary roads, so we'll rename that to primary roads. RRDS is railroads, so of course we're going to name that railroads. And finally, SEC is secondary roads, so we'll name that appropriately. So now let's expand out all our feature data sets again here. So we've got our geodatabase structure set up. Again, a little review. This is our geodatabase. The .gdb extension indicates that that is a personal geodatabase. We have 4 feature data sets within the geodatabase: admin, cadastral, environmental, and transportation. And we have feature classes related to, right, admin, cadastral, etc., stored within those feature data sets. So here's the way I view this structure: is we could consider Octibaha our file cabinet. The geodatabase is our file cabinet. Each one of the feature data sets we could consider one of the drawers within the file cabinet, and then the feature classes stored within the feature data sets are just the different file folders stored within our drawers. Okay, so that's a simple way of looking at the structure of our geodatabase. So we have now created a geodatabase for Octibaha County, which contains some base data. Again, we don't know what the quality of this data is. That's something that you have to make an assessment of on your own. There's always going to be some kind of spatial error, some kind of attribute errors within your data. So last thing we're going to do here is open up ArcMap again and set up a map project by symbolizing all this data appropriately. So I'm going to close Arc Catalog. I'm going to open ArcMap again. And as always, it's going to make us wait here patiently. It's amazing how long 5 to 10 seconds can seem. Now we want to open up a new map document, so again we'll go down to New Maps, My Templates, select Blank Map, and click OK. We already created this folder connection or shortcut to our county data directory, so we're going to expand that. Let's expand Oktibbeha, expand our geodatabases directory, and finally expand our Oktibbeha geodatabase. Now, instead of adding each of the feature classes separately, you can click and drag a featured data set into your map. So we'll click and drag admin. We'll click and drag cadastral. You can just drop it right in the map interface, or you can drop it in the table of contents. Click and drag environmental feature data set. Or I should say click, drag, and drop. And finally transportation. So now we've got all these feature classes. Now you can see these ones are selected and highlighted. If I just click anywhere off of those in the table of contents, it'll deselect them. Smart drawing order, so the polygons are drawn on the bottom. Again, lines are drawn on top of polygons. If we had points, those would be drawn on top of lines and polygons. So let's turn all of these off for now. So I'll hold down Control and uncheck the box for one of these. It'll turn all of them off. And I'm going to turn my county on, and I want to re-symbolize that. So I'm going to click on the color patch right here. And I'm going to select hollow, and I'm going to bump the outline width up to 2. Click OK. So that just defines essentially the boundary of all my data within Oktibbeha County. With cities, if we turn those on, now they're symbolized with single symbol symbology, so they all look the same. So we're going to do a little bit, not super advanced symbology, but we're going to double click on cities to open up the layer properties. Conversely, I could right click on cities and go all the way down to the bottom of the context menu and select properties. But let me click off of that to close that window. I can just double click on it real fast and it's going to open up the layer properties for me here. You can see that we're symbolizing our data using a single symbol. Well, we want to use categories based on attributes. And each one of these city polygons has a city name attribute. So the value field is going to be the name attribute. So we'll click on the drop down arrow here. Let's select name. And then we don't see any values here yet. If we click on add all values, we've got 3 cities in Starkville named Mabin, or excuse me, in Oktibbeha County named Mabin, Starkville, and Sturgis. And those colors look okay to me. If we wanted, we could go ahead and click on the drop down arrow here, select a different color ramp, and select some different colors, but those are okay for now. So let's click OK. Now we can see Mabin, Starkville, and Sturgis within our map. Let's turn on our PLSS sections, and we have a solid fill, so all those polygons are covering everything else within our map. So I'm going to click on my symbol patch, select a hollow fill. I'm going to bump my outline width up to 1. I'm going to click on my outline color, and I'm going to select, I always use this color for PLSS, it's Tuscan Red. So we'll click on that, click OK. Now we have a clear fill for all those PLSS sections. Let's go ahead and click on the water. Well, let's turn water bodies on first. Right? We can see them in our map, but is water typically a light pink or whatever color that is? No, probably not. So we want to make those blue. So let's click on our color patch here. And we see lake symbology right here. That should work pretty well. So we'll select that. Click OK. Now we can more effectively see our water bodies within our map. Perennial streams again run all year round. Let's click on our little color. It's essentially a patch, but it's just the line symbol here. Let's click on that. And we can see rivers right here. So that seems to make sense. We'll select rivers, click OK, and turn those on. Now we can see all our perennial streams. Let's go ahead and turn on intermittent streams. Now these don't run all year round, so I'm going to use a dash line to symbolize these. So let's click on our symbol here in the table of contents, and I am just going to scroll down here, and typically I use like contours, right? Any kind of dash line. We can select contours here. Now I'm going to set the width back up to 1, and I'm going to click on the color patch and just select one of these blue colors. In this case it's Maria blue. Go ahead and click OK. Now we can see that our intermittent streams, right, that symbology makes sense because those don't run year round. We can tell that by looking at them in the map and seeing that we've got that dash line symbol. Now for roads, let's turn on secondary roads, and I'm going to click on my line symbol here, and let's try residential street. And we'll bump that up to 1. Now, let's see here. We'll leave that on a line width of 1 and a color of black for now. Okay. And we can see here's a secondary road right here. Not a lot of secondary roads in the county. Let's do primary roads. So we'll click on that symbol line here in the table of contents. Let's select a major road. That's a line width of 1.5. We can click OK. And now our map's getting a little cluttered here, so I'm going to turn some of these other layers off for now. So I'll turn off my water bodies. Let's turn off PLSS sections for now. We'll turn off our streams. Now here's our secondary roads. Let's turn on primary roads. There's our primary roads, right? See, I symbolized them before, but I didn't have them turned on. So, gotta remember to turn them on if you want to see them, right? Okay, we've got county roads here, so let's symbolize those. Let's turn, and we'll use residential streets again, right? Just because that makes them black right away. Bump that up to a line width of 1. Click OK. And turn those on. Alright, and finally railroads. Now, if we click on the railroad symbol here, here's a railroad symbol in our symbol selector window here. We can select that, click OK, and let's turn our railroads on. And we can see our railroad right here. Now, what I like to do with railroads is you can't see those real clearly. I can't, so we're going to do some advanced symbology here. So let's go ahead and open up our symbol selector again. I'm going to click on Edit Symbol, and I am going to go to Cartographic Line. I'm going to Template. That's what I want. And on Template, you have to play around with this, but by clicking these little template boxes here, what this does is you can see a little preview over here. This is going to make those little hash marks closer together. So here's what our symbol's going to look like now. I'm going to click OK in this window, click OK on the symbol selector. Now you can see the railroads a little bit better. So let's recap what we've done to this point. We went to the MERIS website, the Mississippi Automated Resource Information System. We downloaded some standard county data for Oktibbeha County, which was in shapefile format. We created a geodatabase structure, so we created a file geodatabase. Then we created our featured data sets, 4 of them in this case, within the geodatabase. Those are going to allow us to logically organize our data, and they also allow for advanced functionality that we will explore in a later tutorial. And then finally we imported these shapefiles that we downloaded into the geodatabase and the appropriate feature data sets to create feature classes within our geodatabase. Now we've got all this stuff added to ArcMap, we've symbolized it appropriately, so at this point we want to save our map document. What that's going to do is save all this symbology for us, so when we open the map document back up, it's going to look exactly the same as we have it set up now. So I'm going to go up to File. I could go to File and Save. Let me click off of that to close that context menu. Nope. And I zoomed, or I panned in my map, so I'm going to go back to this button right here, go back to previous extent. And I'm just going to go to my Save button here. Now, where do we want to save this? Well, let's go ahead and navigate to C, Temp, County Data, Oktibbeha, and I'm going to create a new directory here, so I can go up to Create New Folder, and we're going to call that Projects. Right? I typically create a geodatabases directory, a projects directory, a docs directory where I can store documentation. So we'll double click on projects. Now we're in the projects directory, and we're going to rename this project to Oktibbeha. And it's going to have an MXD extension, which is an ArcMap map document. So let's go ahead and click Save. Now you can see that the name of our map document is changed. Now that we've saved it, we can close it, open it back up later. It'll look exactly the same as it does the last time we saved it. So that's the end of our tutorial for now. If you have any questions for me, please feel free to contact me. My contact information is on the MSU Geo Project Facebook website, and I'm happy to entertain any questions you have. Until next time, be good, and we'll talk to you later. Okay? Thanks. Bye. What the fuck is going on here? What? Are you fucking kidding me, dude?